Now let us look at the next problem. Two coaxial solenoids are made by winding thin insulated wire over a pipe of cross-sectional area A, which is given as 10 cm square and length as 2 cm. If one of these solenoids has 300 turns and the other has 400 turns, their mutual inductances. Now you have a pipe of cross-sectional area A. This cross-sectional area A is given as 10 to the power minus 3 meter square. Okay, 10 centimeter square will become 10 to the power minus 3 meter square, and the length is 20 centimeter or 0.2 meters. Now you have winding on this. Okay, so N1 is given as 400 and N2 is given as 300. There are two windings. Okay, now if we assume that there is perfect coupling between the two solenoids, then the mutual inductance M is given by mu naught N1 N2 A by L. Now the value of mu naught is 4 pi into 10 to the power minus 7. N1 is 300, N2 is 400. Cross sectional area is 10 to the power minus 3 and length is 0.2. Okay, now this will cancel out, and if we take this up, this will become 150. So 400 into 150 is 4 into 150 is 600. So 4 pi into 600 into 10 to the power minus 7. So if we calculate this, we will get 2.4 pi into 10 to the power minus 4 Henry as the answer. So option D is the correct one. This was a very simple problem. Now let us look at the next problem. In the circuit below, A and B represent two inputs and C represents the output. Now here we have diodes. Okay, and we know that when the diode is forward biased, then current will flow. If it is reverse biased, current will not flow. Now the other terminal, this end, is connected to a resistor, and this resistor is connected to the ground, or it is grounded. So this is at a lower potential always. The potential of this will be always 0. Now if we apply no low potential at A and B, okay, then this end is also at lower potential and this end is also at lower potential, so there is no biasing, so the output at C will be 0. Now let us say B is kept at higher potential. So let us say we write it as 1. So when this is 1, then there is no current in A, but due to forward biasing in B, current will flow, and this point will be at higher potential C. That C will be at higher potential, so the outcome will be 1. Similarly, if A is at higher potential and B is kept at lower potential, then due to the forward biasing in A, the output at C will be high. Similarly, if we keep both A and B at high, C will also be high. Now this is the truth table of a OR gate. So option D is correct.